Namaste, students. In today's class, we are going to understand a very interesting topic, polyhalogen compounds. Now, this is not just about memorizing reactions. It's a real story with a hero that becomes a villain. Understanding this story will make this topic very clear for your exam.
Sounds strange, no? How can a refrigerator in your kitchen be connected to a hole in the sky in the ozone layer? Well, the answer lies in a special family of compounds. This is a perfect example of chemistry in the real world, so let's understand this properly. So at the very heart of this story, we have the polyhalogen compounds. And, we can think of them as having a sort of chemical superpower. It was this unique property that made them seem like a miracle product for many, many years. So what exactly are these polyhalogen compounds? It is actually very simple. You just take a basic hydrocarbon, for example, methane. You know methane, right? CH4, one carbon atom with 4 hydrogen atoms. Now what we do is we replace more than one of these hydrogen atoms with halogen atoms, like fluorine or chlorine. That's all it is.
To really understand this, let's use an analogy. Imagine the central carbon atom is like a king sitting on a throne. The hydrogen atoms attached to it, they are like small, weak guards. Now we systematically replace these weak guards with the big, strong, bulky halogen atoms. Think of them as powerful bodyguards. These halogen bodyguards completely surround the king, the carbon atom, forming a tough protective shield. A chemical kavach, you can say.
And what is the result of this kavach? Well, because the central carbon is so well shielded by these bulky halogens, it becomes extremely difficult for other chemical reagents to come and attack it. This makes the molecule incredibly stable. The proper scientific term we use for this property is chemically inert.
So this property of being inert, this stability, this refusal to react with other substances, this was its greatest strength. This was its chemical superpower. And this superpower helped us to solve a huge technological problem of that time. Okay, now let's meet the main hero of our story. I'm talking about a compound you have probably heard of, Freon. For many decades, Freon was considered the absolute perfect chemical to be used as a refrigerant. Just look at why Freon was considered so perfect for the job. First, it was chemically inert. What does that mean in a fridge? It means it would not react with the metal parts. It would not cause any corrosion. Second, it was extremely stable, so it could last for years and years inside the appliance without breaking down. And very importantly for household use, it was non-toxic and also non-flammable. So there was no risk of fire or poisoning. It was completely safe. So I want you to appreciate this point. This chemical stability was not just some minor property. No, it was a massive technological achievement. This is the property that made modern refrigerators and air conditioners possible and safe for every home. But the story does not end in the kitchen. The very superpower that made Freon a hero inside our homes, well, that same superpower became a terrible problem once these molecules escaped into the atmosphere. So think about it. Over many decades, whenever an old refrigerator or AC unit leaked or was disposed of improperly, these super stable Freon molecules were released into the air. So my question to you is, what happens to a chemical compound that is so stable it almost never breaks down? The answer is nothing. Absolutely nothing happens to them in the lower atmosphere, what we call the troposphere. They are so inert, rain does not affect them, they don't react with other gases in the air, they are basically untouchable. So they just drift, they float upwards, slowly, completely unchanged. And this slow journey, which can take many years, carries them higher and higher until they reach the upper part of our atmosphere. They go all the way up to the stratosphere. And what is waiting for them there? Our planet's protective shield, the ozone layer. And it is here, high up in the stratosphere, in a completely different environment, that our hero's superpower is exposed as its greatest weakness, its hidden, fatal flaw. This is the main point, the irony of this whole story. Down here in the lower atmosphere, its chemical inertness was a benefit, a blessing. But up there, in the stratosphere, the exact same property became a liability, a curse. And why is that? Because only a molecule that is this stable could survive the long journey up to the ozone layer in the first place. Any normal molecule would have been broken down much earlier. So let's see the mechanism. What happens up there? Once the stable Freon molecule reaches the stratosphere, it is hit by high-energy ultraviolet radiation from the sun. Now, this UV radiation is powerful enough to break the strong carbon-chlorine bond in the molecule. When this bond breaks, a single, highly reactive chlorine atom is released. We call this a chlorine-free radical. And this single radical, it starts a devastating chain reaction. One chlorine radical can destroy hundreds of thousands of ozone molecules before it is finally removed from the cycle. It acts as a catalyst for destruction.
So what is the final takeaway from this entire story? What is the lesson for us as students of chemistry?
See, the story of Freon is not just about one compound. It teaches us a much more fundamental lesson, a lesson about how we must evaluate the properties of any chemical substance.
And here it is, the most important sentence of this whole explainer. A desirable property in one environment can become a very undesirable liability in another. The stability that was a good property in a refrigerator became a bad property in the stratosphere. So what does this teach us? It teaches us that in chemistry, context is everything. No property is good or bad in isolation.
Okay, so let's do a very quick recap. Point 1. Polyhalogen compounds are very stable because the central carbon is shielded by bulky halogen atoms. Point 2. This extreme stability made a compound like Freon the perfect refrigerant, non-toxic, non-flammable, and non-corrosive. And point 3. This exact same stability allowed it to survive the long journey up to the stratosphere, where it then caused the destruction of the ozone layer.
So for your exam preparation, please don't just try to by heart the reactions. Instead, remember this story. Remember the core idea of stability. Remember that mental picture of the shielded molecule, the kavach. And remember the example of Freon, the hero in the fridge and the villain in the sky. If you remember these three things, the idea, the picture, and the example, I can assure you this topic will feel much, much lighter. All the best.